And welcome back to 3.2 podcast. We're dealing with the International System of Units. And as we're scrolling down here to the second page of the units, we're going to be talking about temperature in this section. And first of all, we're familiar with the Fahrenheit system, or the Fahrenheit scale, degrees F. But commonly in the world, we're dealing with degrees Celsius, and in some parts of science we're going to be dealing with, and some parts of this class we'll be dealing with Celsius. But oftentimes we have to turn things into what's called the Kelvin scale, which is denoted by K. That's the absolute scale. First of all, how do you determine what a temperature scale is? Well, as I scroll over here and scroll down, you can see a couple of thermometers. The Celsius scale is based on two events. It's based on the freezing point of water and the boiling point of water. And they say that water is going to freeze at 0 degrees Celsius and it's going to boil at 100 degrees Celsius. Why? Because they just wanted to. It's a somewhat arbitrary scale. And then they put 100 increments in between, all the way on up to 100 degrees. And that's how you get your scale. The Fahrenheit scale, which we're not going to study a tremendous amount, 0 degrees Celsius is the freezing point. So we'll just say it's the freezing point of salt water. And 100 degrees is body temperature. That was developed long before the Celsius scale, and the problem with that particular scale is that salt water is not consistent. As you learned in chapter 2, it's a mixture, and mixtures can vary in composition. So how do you say what exactly your salt water is going to be? Well, that's a problem. And then also body temperature fluctuates from person to person and throughout the day, so that's not a fixed amount, and so it's not even at 100 degrees Fahrenheit anyway. But the bottom line is that scale, though we have it and we use it, it has its limitations. All right, when you go to the Kelvin scale, is basically the Celsius scale. It uses the same increments, meaning that 1 degree on the Celsius scale is the same as 1 Kelvin, but the 0 is not the same. 0 Kelvin is theoretically the coldest temperature that you can achieve, and it's at a negative 273.15 Kelvin. But the 1 Kelvin, if I bump up 1 Kelvin, I'm actually bumping up 1 degree Celsius, but it's not the same between Celsius and Fahrenheit. Let's do some comparisons here to kind of put this into perspective. I'm going to scroll back over to the other side, and so let's do some conversions, and maybe it'll make some sense here. Let's start with, say, 70 degrees Fahrenheit. That's just, about room temperature. It's a very comfortable temperature for all of us. If you were to change that into Celsius, which we're not going to make you do, since we never measure anything on the Fahrenheit scale in here. But if you were to convert 70 degrees Fahrenheit into Celsius, it is approximately 21 degrees Celsius. If you picked a very, very hot temperature, let's say you have a scorching day in the summer, 100 degrees Fahrenheit. 100 degrees Fahrenheit is actually going to be 38 degrees Celsius. Approximately. And if you went to the other side, down to a frigid day, get down to, say, 0 in the wintertime, that's an incredibly cold temperature, at least for us. It's not unheard of, but it is very, very cold. That's going to be a negative 18 degrees Celsius. So that kind of puts things into perspective. Something in the low 20s is fairly comfortable to us. Once you get into the 30s, it's getting warm. When you start pushing 40, it's going to be very, very hot outside. And then once you get down into the negative degrees Celsius, that's going to be pretty darn cold out. Now, when you change that into Kelvin, notice to change from Celsius to Kelvin, all you need to do is add 273 to your Celsius temperature. So when you add 273 to this, that's going to be 294 Kelvin. That is a very comfortable temperature. When you add 273 to your 38 degrees Celsius, excuse me, that's going to be 311 Kelvin. And when you add 273 to your negative 18, what is that going to be? What, like 255 maybe? 255 Kelvin, yeah, I believe that's correct. Anyway, that gives you a little idea on what these temperatures are. So now you can wow your friends. It should be, when you're watching this podcast, it might be a very warm day outside, and you can impress them by saying, "Wow, it's got to be pushing 310 Kelvin," and they'll think that you're pretty sweet. Or if it's a very comfortable day outside, you could say, "Well, it feels like it's in the 290s, the 290 kelvins." But when it gets cold, you're getting down into the 250s and 260s. That would be a fairly cold temperature on the Kelvin scale. And you should practice that. Now you can obviously go back the other way by subtracting the 273 back out of the Kelvin temperature to get back to Celsius, and you will be expected to do that on tests and quizzes. All right, and so here's, again, and you do not have to memorize those temperature conversion equations. They will be given to you. Now the last thing that we want to talk about is energy. And we'll scroll over just a little bit, see if we can't fit all this on one screen. There we go. The SI unit of energy is the joule, which is given the symbol just J. And it's the SI unit for energy or for heat. Heat is a form of energy, but it actually can be used for any form of energy. Another common unit that most of you are more familiar with is calories, which is the amount of heat. 1 calorie is the amount of heat required to raise 1 gram of water by 1 degree Celsius. The joule is defined in terms of physics, and so we won't get into exactly how that is determined. But the calorie has a very simple definition of taking 1 gram of water and raising it by 1 degree Celsius, and the amount of heat that is required to do that, that's a calorie. Now, that particular calorie is not the food calorie. From what I understand, my understanding is that 1 food calorie is the same as 1,000 regular calories or 1 kilocalorie. That's what I've been told. I should look that up, but that is my understanding of that. Okay, and you should be able to use these conversions. I will be showing you how to do those conversions in the next section. Okay, so that concludes 3.2, which is just simply an introduction to our system of units. Hopefully you have a little bit better understanding of what they are and a little more comfortable with it as you use them in class and as you use them in lab. That's really where it's going to make more and more sense to you. Okay, and we'll see you in the next podcast for 3.3.